And it's sort of like that song, Johnny Paycheck, take this job and shove it. I don't have enough energy to work as a liver cell, so I'm just going to become a liver cancer, replicate myself, and go metastasize somewhere else. So that's how I see the main overview of cancer. There's obviously a lot more to it than that, but that's the big step, switching from oxidative metabolism to anaerobic metabolism, and switching from a worker pathway to a growth pathway.
Now, at least when you first covered it on your YouTube channel, that was one of the most fascinating things to me. It was you were not directly talking about like, okay, there's damage happening to the DNA, it's damage to the mitochondria, which I think is a big aha moment and a bit of a switch that goes on. Do you want to talk a little bit about why we, or the evidence that we have on why leaning towards basically mitochondrial dysfunction versus like cell nucleus or DNA dysfunction?
Well, yeah, this goes back to the concept of what's your theory of disease.
Mm-hmm.
And it's very important because the theory of disease, what is causing the disease, that determines how you treat it. So conventional medicine completely goes by what is called the DNA theory. It's also called the SMT, the somatic mutation theory, the idea that a chemical damages the DNA, causes a mutation, and then the cell grows out of control as cancer. But I think that's, for the most part, a bunch of nonsense. The data does not support it. The best book written on that subject was called Tripping Over the Truth by Travis Christofferson, where he wrote about the fact that the Cancer Genome Atlas project showed that they couldn't find any consistent pattern of mutations in these cancers. And not only that, some cancers had 0 mutations. And what I think is happening is you're basically switching over to what I would call the hypoxia pathway. Like when a cell is hypoxic, you activate something called hypoxia inducible factor. It becomes activated, it goes into the nucleus, it binds the hypoxic response element, HRE, sort of promoter region. And you don't change one gene, you change a whole bunch of them.
Yeah.
You revert to a form of anaerobic life. And all cells have the same DNA. And in a sense, I think this goes back to the beginning of life on Earth, whereby oxygen availability was intermittent. So a cell keeps that ability to run anaerobically as an option. It's buried deep within its DNA, and you only turn it on. But then when you start reading it some more, you realize that, gee, there's other times when a cell turns on anaerobic metabolism.